Hello, my name is Patrick and I am one of the engineers behind XCMetrics. We created this tool in order to track Xcode build metrics for our teams. First, it collects all of our team's build logs. These logs are produced by Xcode whenever anyone runs a build. Then, XCMetrics parses the data, build times, errors, warnings, whatever we want to extract from the log files. The data is stored in easy-to-manipulate tables, allowing us to look at historic build metrics for the whole team any way we want. We use these metrics to answer questions we have about productivity, like, are our build times getting better or worse? Which version of Xcode is the slowest? Which hardware setup is fastest? XCMetrics makes it easy to find all this out and even more. And of course, we use these insights to improve our developer experience. In this video, I would like to show you how easy it is to integrate XCMetrics into any Xcode project. We need to start by downloading a release of XCMetrics, where you will find two executables, the README and the license. For this example, we are going to use the Kickstarter iOS app, which is open source and available on GitHub. The first step is, of course, to integrate XCMetrics as a binary. You can compile it locally as a Swift package manager module, or you can simply download it or check it in your repo. Here, for simplicity, we checked in directly the executables together with the README and the license. The next step is integrating XCMetrics into a post-action scheme in order to upload every build. To do that, select the scheme, press Edit Scheme, expand Build, select Post Actions, and create a new Run Script action. Make sure we are providing the build settings from the Kickstarter iOS scheme. We can then proceed to paste the actual script. The script is invoking XCMetrics Launcher, which is a wrapper executable that makes sure that Xcode doesn't wait for our upload. We can then pass the actual XCMetrics executable together with a few arguments: the name of the project that we are tracking, the build directory, and the service URL. This service URL is the URL to the service that you should have deployed in the cloud, either on AWS, Google Cloud, or really any other infrastructure. After that's done, you can press Close and save this. We can now proceed to trigger a build and upload its log. To do that, simply do a normal build. Product, build. This is a clean build, so it will take a while. As you can see, the build succeeded. We can now take a look at how the log was produced. This is the Kickstarter derived data directory. If you open logs, build, you will see all the XCC activity log files produced by Xcode every time you build your project. This file contains all the information that we need from the build. XCMetrics copies this log into a cache directory, which is namespaced with the name of the project. As you can see, the name of the log is exactly the same, but with uploaded appended at the end. In this way, we have signaled that the log has been uploaded correctly to the XCMetrics backend. This is an experimental website that shows all the builds collected by XCMetrics. As you can see here, we have a build that we just performed. It shows the duration, which is 2 minutes and 33 seconds. It was categorized as a clean build, and it shows also the host and the username redacted, as well as the status, the errors, the warnings, and some more metadata. Under Jobs, we can also take a look at the ingested and parsed logs to make sure everything is working as expected. Let's now go back to our project and try to make a build fail and see what happens. We can simply introduce a syntax error. Let's introduce a new character to the import. After building, the build should fail. As you can see, Xcode produced a new log for the failed build, and XCMetrics already uploaded it as well. We can now go back to our experimental website, and we can now see that we have a new build which lasted 5 seconds, was an incremental build, but the status was failed. We can press on the error to see more details about it. As you can see, we can see a very accurate description of what the error was, as well as the file location with the redacted user information. There is an even more powerful way to take a look at your data. I have now connected to my PostgreSQL database. As you can see, there are many partition tables where we can see all the data collected by XCMetrics. For example, we can see the builds collected today. Here are the 2 builds previously uploaded. We can see all the information with some more metadata. For example, how many files were compiled during the build. The build auth table contains more information in regards to the machine that compiled the project. Here you can see the host model, the CPU model, the macOS version, and much more. Another interesting table is the build metadata. This table is now empty, but in case you use a custom XCMetrics, you will be able to collect all the information you need in your table. You could collect information such as your project configuration or any other information related to your specific project. We can now take a look at the build steps. Build steps contains 1 row for each step of the project. As you can see here, this is a step that compiled the app delegate. We can see more information about it, as well as the duration and if it was fetched from cache. Similar tables exist for build warnings as well, and for Swift functions, type check information, for example. We also collect information in regards to the Xcode versions used by developers. In this way, you can actually see which Xcode versions your developers are using the most. As you can see here, I was always using Xcode 12.0 to compile the project. As you can see, we did our best to make XCMetrics as simple as possible, so that it would be as easy as possible for you to customize. We can't wait to see how the community customizes XCMetrics, which metrics you'll track, and what new insights you might share with us. Thank you for watching.